You're doing still at work.
Well, I didn't want to have the same problem with the audio, so um,
Ah,
yes, that was very annoying to have bad sound quality. So, and look, we've got lots of people here.
yeah. You're popular tonight.
Mhm. Okay.
Oh, we'll make a start in a sec. Welcome, everyone. This is our very last gathering of the IoT capstone. Hope you've enjoyed yourself. Hope you got something out of it. I would really like if you could drop an email to us with any feedback that you have, the good, the bad, the ugly, what didn't, etc. It is our first time. We'd like to know how it went, get the student perspective, so that we can make improvements for next time round. Um, okay, we can hang around for a bit of a chat afterwards if anyone's got anything they'd like to say, but I'll hand over to Valerie now and we will get into your presentation.
Okay. See how this goes. Let's set up this time.
Good so far.
Okay. All right. Uh, okay. So you've had a whirlwind tour of what's involved in IoT, and I think you've done some amazing projects as well. So very well done getting all the way through. You should congratulate yourselves. Um, I'm going to talk a bit about data presentation and insights, how we um, go from the information that we're getting from the sensors and then start to present it, and what your different options are there. Okay, so we'll start with a little bit that sort of revises a bit of the earlier modules. So the types of data, the presentation options that you have, some of them are in dashboards, so we'll have a few examples of them, and then looking at work, what options you have around predictive analytics. So after you've got the data, can you do a little bit more in terms of um, exploring the data, understanding the data, and seeing patterns in the data? And then how do you go from that to maybe making changes in your organisation? Okay, so we've set up some things in our Internet of Things. You've learnt about how the electronic side of it, how to work with the hardware, and then how to connect them up and get information off them. Um, and we needed to take that information and then get it into a format or put it into a place where we could do some analysis. And it's coming from lots of different places and it's coming in streams. It might be at different data rates, all sorts of different things that we have to deal with before we can actually bring it together and do some analysis. So we've got our sensor data, we've got maybe time series, it's usually numeric data that's coming through, floating point numbers. It might be telling us about orientation and movement of a device or of people. Might be looking at temperature or light. Um, just getting a lot of information because we have that opportunity now. Everything's quite cheap. We can have these sensors and lots of them available to get that information. And it might be videos and images. So we've got larger data that we might be, or more complex data that we might be looking at. And Dave took you through locational data in the last presentation. So it might be that you've got things that you can map as well. So that's a useful thing to use. Or it might be something as simple as a count. So you're keeping track of how many times an event happens rather than a value for how large um, a movement is or an absolute value for a sensor. So we've got all of that data coming in from our channels and it's coming in a raw state. This was covered in the earlier module. So the sensors themselves, they don't know where their data is going. They're not aware of their part in your project. So you need to be able to tag them up and keep track of what information it is that you actually want because you can send a lot of data, but that just means you've got more work at the other end. So keep it down to what information you really need, and that might mean that you encode or decode the data, do conversions, so you might have metric to imperial, um, just in terms of units, making sure that all your units are consistent. or you might be stripping out extra data or reducing resolution, reducing the number of the precision of the data because it might not be necessary. And any amount of data that you're sending is costing you in data transfer, it's costing you in power for those transfers, and it's costing you in space for storing it and time for processing it. So really, really important to reduce the data where you can. You might have some other data sources that you can use as well. So looking at weather data perhaps that you can combine with the data that's coming from your sensors to give an overall correlation. So that might be that there's a dependency or an impact that the outside temperature has on what you're studying. So then it might be that you need to take that into account to see patterns. And then we can put some statistical tools on our data sets just to initially to be able to check to see that the data is clean, and then later to start to see some patterns. So you would have seen this diagram before. So we start with the raw data, and we want to check the types, make sure that all the data is what we expect it to be, and get all of the matching types, because we might have some some things that are numeric and some things where there's not a value. It might say not a number or have something that isn't of the same type. So we've got to make sure that it is something that we can work through, because that tends to crash programs when you've got different types of data. Then going through, fixing any problems with it and getting it technically correct. So we don't care exactly what the values are, but we're making sure that they are all the right type so that we can then throw some statistical tools at it. But then looking at that data, looking through, initially doing this manually, looking through your data to see if there's anything that you need to adjust, anything that looks out of place, because you can correct for that. It could be actually a hardware problem, but you need to be able to look for that before you put too much stock on what data is coming out and make some decisions based on something that might have errors in it. Okay, so then we've got our data to the point that it's consistent, and at that point we can start to do some analysis and perhaps draw some conclusions. So it's important to go through this manually at first, make sure that everything coming off your sensors and everything coming into your stored data is correct. And if you can document that, because you need to make sure that anything that's coming off your sensors, any of the changes that you make to that data are recorded, and then you can automate them. So you can document and automate them, then you can always work back to see where the data came from and what problems there might be. But automating it means that you shouldn't have to touch it again. So it's only when you change your hardware or change your setup that you would actually have to go through and make changes. So from a case study that was in the previous module, Jack Downs did this case study where he was looking at the different materials that they may have been using for building for one of the local councils here. And so it was looking at temperature data across the day and whether the temperature was, how quickly the temperature went up in that material and how quickly it dissipated. So his first step was to clean the data. So we can see that we've got these two lines here where we're looking for a particular value that we know is incorrect in the data. So we know if there's a 0, really unlikely, but apparently possible to have a 0 degrees Celsius temperature reading in Perth, Western Australia. We tend to be a bit warmer than that. And it's impossible to have it 85 degrees, pretty much. So these were shown by looking manually at the data to be bad data points that could be turned into not a number, so saying it was missing data. So once we have those data points cleaned out, and then our way of dealing with it was to drop that data from our data set. So drop the not a numbers, and if any of the values in that data point have not a number or have got a missing value, then they're dropped from the data set that gets sent through. And the last line here is looking at the date time and changing the format of that as well. So then we can know that we've got the correct format, and we would do that across all of our sensors to make sure they're all consistent on format. So we then have some clean data that we can go back, and that's saying it's consistent. It's not saying that we know anything particularly about the data, but we can work further with it. So then looking at that, we've got our sensor data that's come through. So that's sensor 7 on a Thursday. It's just a CSV file. It goes through that data clean process, and then we're combining that with some Bureau of Meteorology data. So the Bureau of Meteorology in Australia is looking after collecting and sharing weather data, so we can get local weather information from there. And so we take that and we also put it in a CSV, and we make sure that everything is matching in there in terms of going through that same cleaning process, which will give us the same. Make sure that we're looking at the same time period. So we've got the start and end time periods for each of them, and then we can graph each of those time steps. So on here we've got the first one is plotting the sensor data, and then with the same settings except for a different color on a line plot, we'll plot the Bureau of Meteorology data and get something that looks like this. So once you have the consistent data, once you align and make sure that your types and your formats are correct, then you can start to present the data to be able to see any patterns that are going on. You can see a very strong correlation between the weather from the temperature data from the Bureau of Meteorology and the information coming from the sensor. Okay, clearly it gets much hotter than the outside weather because it's sitting in the sun, and you can see some blips in here of different spikes in the values, so that's something that would be of interest as well to see how correct that data is. Okay, so when we've got our data, most of the tools, particularly with Python, with Matplotlib, you can go through and plot your data with many different formats. So this chart is a really good one to have if you're trying to decide what type of plot would be appropriate for the type of data that you're looking at and the type of insight that you're wanting to get. So looking at if you're doing a comparison between values, you might go for your regular bar or column chart. You might look at a circular area chart, which can be an interesting approach to comparing data sets on multiple characteristics. So it can have a graph of one data point across 8 criteria, and then another data point would be in a different color, and you can see the overlay and the mapping of them, which applies to quite a few interesting problems. In line charts, if you've got something that's continuous, that's changing over time, line charts can be really good for that. There's also relationships, so you might have a scatter chart to have X and Y values that vary independently and see what patterns you might see or clusters that might form in your data, and then going through comparing position and composition or the distribution of data. So over time, you might see that you have a histogram of your data and be able to see how often different values come up, which would be useful as well. Okay, so with that, we can start to say, okay, we've got consistent data. We can send that up to perhaps a dashboard to do some visualization and be able to watch the data set in real time. So there's a lot of options in terms of dashboard services. So the steps involved, you'll have your sensor or the information that you want to send. You register your device with that cloud service. Then in the dashboard, you'll check which display options that you want. You might be able to put in some alarms and notifications. So if a value goes over a particular threshold, it might change the color or make a noise, or it might send a text or an email to someone, or send a signal to an actuator to make a change based on an issue or problem that might have occurred. Okay, so we can publish from the device to the service, or we might be able to control the devices that we have from the dashboard service as well. So some examples that are around, so ThingSpeak, Freeboard, IFTTT, so if this, then that, ThingsBoard, initial state. So there's a lot of different options there. They tend to be subscription services that you pay when you start to use over a threshold of data going through. And it's something to explore a few of them, go through their tutorials to see how they work for you. Let's see. So this is an example from ThingSpeak. So you've got your different channels coming through. You can select parts of your data set. You have multiple charts up at the same time. This one has temperature and humidity. You can see them going with the same time scale. So it's making sure that the timestamps are equivalent, and then obviously different scales for humidity and temperature. Another one, Freeboard. So this gives you an idea of what's inside Freeboard for setting up your different sensors and registering the information, and then being able to choose what sort of gauge, what sort of representation of a tile or a widget for your data shows up on your dashboard. And in this case, it's a temperature gauge. Okay. This code here on the right is an option to embed a gauge or a widget on another web page, so you're not restricted to just having all of the gauges on a dashboard. You may have another web page that's your home page that is keeping track of the availability of services, perhaps. So you could have just insert this code in one of your web pages in the HTML to have a widget appear and be working with your dashboard. Okay. Another image from ThingsBoard, so looking at tracking multiple buses, and they've done a really good job of making this quite intuitive because they've got the speed of the buses looking like the dashboard of a car or of the bus, and the fuel levels on each of them as well, with color coding to see what the thresholds are in terms of it being in having enough fuel, or whether it has to go and refuel soon. And then they're also color coded, so the 4 different buses, the color of the buses and their positions on the map are matched to the information about their speed and fuel level. So it's very, very readable, and a lot of information included in a quite dense space. So it's a very impressive setup. Okay, so again, in ThingsBoard, looking at setting up and registering your sensors, but what you can also add in terms of how it can interact with your sensors. So posting the attributes, just putting some information up, putting the telemetry, so what data is coming off your sensors, getting a request from the device, so it might be asking for an action to happen or sending a request to a device. And of course, on top of all of this, you would have to be looking after your security, because if these requests are coming from external, they have to come from the right place. Okay. And one that I'm enjoying at the moment is initial state. So that's looking at another dashboard. It's got some very good widgets and tile options there. Nice visualizations. You can see this is 2 animations of dashboards that they've got, and they also have the mobile phone version, so you can take your dashboard that you've developed, copy it to a new dashboard, and then resize everything to fit nicely on a mobile or on a phone, so that you can see it all at once and not have to be scrolling to see something that's in landscape instead of portrait, for one thing. Okay. And they've also got, and all of these dashboards have different skins, different settings. So this one is the white background, the light background. And you can see that they've brought in data from darksky.net to say they're keeping track of office humidity, office temperature, the UV index and those sorts of things. So they're combining the weather from this darksky.net service with their internal sensors to get an overall picture of what their office space status is. And they've got widgets so that you can have, instead of just having graphs, you can have icons to represent different values, and that makes it much more readable and intuitive. I'll see. After I finish, I'll show you some more about initial state. Okay, so we can be storing and processing our data in a dashboard, but once we get a lot of data, the real-time data can go to a dashboard, but we might want to combine that with some static data that we've been storing and be able to do some more interrogation of the information that we've developed over time. So we might choose to store our data in the cloud, and we've talked a little bit about processing in the cloud in terms of having instances, and we went through in the module how to start up an instance on Amazon Web Services, but we can also use it as a place to store our data. And that may actually be more of a useful service for us. So we could have our devices and have our processing through an instance. We can have a dashboard, but we can also be storing our data there as well. So there's quite a few options for storage, and for example, Amazon Web Services storage options, they've got S3, which is their main way to store data for regular access, and that has 11 nines of durability, so it's looking at very, very high quality service because they have a lot of redundancy across their data centers across the world. And so there's automated redundancy, automated duplication of your data so that you don't even notice if there's issues with their hardware. Okay, that's something that's very difficult to do in-house. So you've protected against failures and errors, and other cloud services can do this as well. And you would have a free 5 gigabytes of storage and 20,000 read requests per month for free. So once you go past that, yes, you have to pay, so you have to be careful of that, but it's also an easy service to be using. And if you align that to where your dashboard and where your other instances and processing are happening, then it means it's all together and easy to access. And you may combine larger data sets into a data lake that you can start to really explore. So that's another concept that's coming up. Again, you could do that combination through Amazon and perhaps archiving your data as well, so you don't have to pay so much for keeping all that data available immediately all the time, but you do want to have it. So you can automate the process of taking your data from the S3 storage, which is your day-to-day storage, and put it into an archive and know that it's available, but you're not being charged anywhere near as much for using their Glacier archival storage. So you do need to plan for your data storage and the management of your data, because it does cost, but it's also, you need to be aware that you have to be ready to be able to pull that data and be able to perhaps justify decisions you've made based on the data, in which case you need to document all your sources and how you've processed it, the provenance of your data. And in terms of cost, you need to make sure that you're not storing things that you don't need to. You might, as I said earlier, reduce the amount of data that's coming off your sensors, reduce the resolution, so downsample your data. And it might be that you go through multiple stages of processing your data, but you don't need to keep what's in the middle. So you might keep your raw data and keep the final version of your data. And if you needed to reconstruct the data, you could rerun your code, but you don't need to keep all those intermediate versions, so we can reduce the data storage that way as well. Okay, so one way to deal with big data is to make it less big. So don't store it all, just to keep the data that you need. Okay, so if we've got large amounts of data, we can display it, we can do statistical processing, we can present it on a dashboard, but if we want to really be looking at patterns and be able to predict based on those patterns, we need to look at a higher level of analysis. Okay, so this is enabled by machine learning. So between having all of the cheap sensors and the basis for the Internet of Things coming from the hardware. It's also that we have access to processing through the cloud that lets us be able to do on-demand processing of big data sets and churn through and be able to find patterns with these tools, which are now available in open source, so that you don't have to write your own classifiers or neural networks. You can use packages that are open and available. So we can apply machine learning to be able to create models. So instead of having to write programs that say, do this step, do the next step, do the next step, and then plot data, with machine learning, we have algorithms that can come to a conclusion that we didn't expect. So they look through and they look for patterns. They make decisions based on classifications of all of the inputs that we have available and an output, response or decision, and then they connect the dots in the middle. And so by connecting those dots, the next lot of data that you give to it might be a combination of values that you haven't seen before, but through the model that was created with machine learning, it can make a decision and give you an output or a result on that data that it is learned from previous and historical data. Okay, so we can find new rules and discover new things using machine learning. Okay, right. So because we care about what the end goal is, the overall decision, and how that connects to the input data, we don't have to really care too much about what's happening in the middle, or that's the way that the world's gone now. We used to have to justify our decisions, but now with machine learning, people are happy to let a black box model make the decisions for us. There's lots of applications for machine learning. We've got predictive maintenance, so being able to perhaps listen for changes in the sound of a piece of machinery which might be a clue to that it might need to have maintenance or it might be about to break down. Checking to see the habits of perhaps good drivers amongst a pool of drivers, and then say, well, if it's about the behaviour of the drivers, we might be able to coach our other drivers to drive more effectively and reduce the amount of fuel that they use. So in one company, it was a 15% reduction in fuel costs overall by looking at the driver behaviour and finding the ones that use the least fuel and getting the others to drive like them, which is a significant reduction in cost for them. Yeah, and then I guess image analysis, so for looking at large data sets as well. There's a lot of different applications, which I guess we all know about. The impact that has on our systems that we develop is that if you have a look down here, the pink area is what would typically happen, where we'd have our information coming in, being stored and doing analysis, doing our monthly or annual reports to get some information out, maybe doing some business intelligence, so putting it into a data warehouse and being able to look at it. What we can do now is the part in blue, where we start to be able to do things in real time. We've set up some models to be working on the data in real time and give feedback and make changes to or have actions on our systems, on our processes to be able to improve and optimize our overall functioning. So this real-time feedback loop and then the data coming back in and being able to adjust automatically with the analytics that has come from this historical data is where the changes have happened. So we will start by looking at determining the problem that we want to address if we want to apply machine learning, and then look at the size and type of data and getting it into the right format to be able to put into one of these tools. So although this is model identification, what tends to happen now is a lot of a suite of different machine learning algorithms will be used on the same problem and then trained and tested to see which one's the most effective or the most suitable for that problem. Because we've got access to a lot of processing power, we can just use the cloud and run lots of these models. It's not about saying we have to choose the right one up front. So we might use 4, 5, 10, 20 different models and then see which one gives the best results, or maybe do a combination of them. So once we have worked out which one's performing best, we can deploy it and we can do some visualization and have that feedback and action based on the machine learning outputs. So overall, it looks like, machine learning sounds like a big thing, but in the scheme of the work that has to be done, machine learning code is this tiny bit in here that depends on all of the rest of this being done well. So the configuration, the data collection, data verification, process management tools, analysis tools. So we've got to have a lot of extra information and all of these resources being looked after to be able to do machine learning in the middle there. Okay, and the feature extraction is talking about we've got lots of data coming in, but which is the right data to look at. We don't want to have 4 sensors with pretty much the same values coming through, because that can actually cause real problems for machine learning. And then in the bottom half, it's really looking at all of the people involved and which part of the process they'll be involved with. So data engineers and data scientists looking at getting all that data and putting it into the model and training them. But at some point it starts to be a blend between them and the production engineers and the people that are out there on site doing with the hardware and with our machinery, and they have to take what the data scientists are sensing and getting that information out of machine learning and action that and work out what that implies and what changes have to be made to the live system based on that. And then perhaps also saying, okay, we could do this even better if we put some more sensors in different places. So it is again a feedback loop of through a team of people working with lots of data and lots of different compute. Okay. So the different tools for machine learning, the frameworks include TensorFlow, which has come out of Google, the Google Brain team, so that's quite commonly used. Amazon Machine Learning, Microsoft Azure Machine Learning as well. So these big companies have developed their own software, but they've made it available for others to use. And then you can also look at packages within languages like Python, so scikit-learn and Keras, where we can look at machine learning and neural networks as well. So the Python programming or other languages can just be taken in and import these different machine learning frameworks to do the work. So you're not really having to implement much yourself at all. Okay, so in conclusion, we've got lots of data that's coming in, and it's a big challenge to work with that data. There's the 4 V's, the volume, the velocity, the veracity, and the variety of the data that we have to care about. And we can deal with that through automating the cleaning and pre-processing of the data through scripts, reducing how much data we have if possible, and then using dashboards to display the data and set alarms so that there can be some response to a straightforward version of the data. And then if we want to do more in terms of predictive analytics, we might put new patterns and solutions or find new patterns and solutions with machine learning. But we need to make sure we're defining what our problem is that we're looking at. So what's the metric you want to optimize? Is it reducing the amount of fuel that you're using? Well, then you need to collect the data that matches to that metric that you're interested in. I guess at that point we've taken you through your MicroMasters in IoT, and Ian will talk more about that. But another option or a future space that you might want to come into is predictive analytics at Curtin University. So we have the Masters of Predictive Analytics, the Grad Dip and the Certificate, so 3 versions that take 6 months, a full year, or 2 years. And that gives you a very strong basis to be able to apply these machine learning tools in the real world or to your discipline or domain. So if you were interested in coming to study that with us, there's a graduate certificate, which is 4 units where you study the fundamentals of programming, so more Python for you, and that's one that I teach. Data management, fundamental concepts of data security and decision methods and predictive analytics. So you start to get the basis of being able to process this data with the grad cert. And then the second semester, going further into data mining, management and organizational behavior. There's very much, it's the programming, it's the AI, it's the statistics that you need for all of this sort of work. So we look after that well in this course. There's 3 streams that we have. So the main ones are the resource operations and finance and investment streams. And we're looking at AI and data analytics and a health informatics stream as well. Okay, so in a stream, you might do another 8 units in the second year, and they're far more specific, and then also working on projects with industry. Okay. So it is something that would be available to you now. It is, we would give some credit for prior learning for having completed the Masters in MicroMasters in IoT. So it is something that perhaps you can consider going into later. It is on campus at the moment, but they will be looking at online options as well going forward. Okay. So I just wanted to show, it's the screen that's, sorry. So the initial state has lots of lovely tutorials, and this gives you an idea of how easy it's becoming to be able to get data into one of these dashboards. So this code here on the left in Python goes through, it sets up the access key to my account. It indicates what the bucket key, so within all of my dashboards, which bucket of data am I talking about, and giving it a name. We import a package called ISStreamer that's written by the initial state people, and I've just got a loop that's going through generating 10 random numbers. Probably make that bigger. So it's just a loop going through 10 times, generating a random number, and then this goes into a log, so it's combined into a bundle of data to reduce the amount of transfers that you have to do. Then the streamer.flush sends it through, and I've got its printing done to show that it's doing something. And if I just run that and look across at the right, you can see that that data is updated in the dashboard. So I can just keep doing that a few times, and you can see that from a very small piece of code, we're going into a dashboard. We've got 2 different types of graphs coming off that, and it's very straightforward to work with. So just gives you an example of what would be involved, and there's tutorials for all these sorts of things with any of the dashboard options that are out there. And I think Ian's got some good ones that he'd also be able to show shortly. Back to you, Ian.
Okay, thank you, Valerie. We just had a good suggestion in the chat there for a LinkedIn group, since we have a Facebook one. So I just created one. Links in the
That's
chat
a good idea.
And we shall invite or get the word out to our graduates shortly. Right. Well, while you're thinking, if there's any questions, please raise your hand and speak up. I'll share my screen. Actually, I better become presenter again. Okay. So that's a group I've just created. So we can keep in touch there and work out a way to get that out to everyone. Some of the ones that I particularly like, as far as dashboards go, is Thingsboard, which Valerie's already mentioned, but there's a nice little example up here that you can try out and see how they put it together. And it's a set of silos in Switzerland. We can go in and have a look whereabouts in Switzerland. Zoom out. Links a little. There we go. But this is not a screenshot, it's the actual dashboard running. We can see that there's the 3 silos here, the temperature. We get warnings when things are going wrong, like the silo temperature is low. We can actually see the values of the temperature, humidity, and weight changing as things are done very clearly, very easily. As I said, I quite like Thingsboard. It's nice and easy to use. Another one that we've used successfully in a course we ran in Burma. We had a case where we were teaching the Internet of Things without the Internet, pretty much. But we used Lossat, and that was rather useful because the project we had was a self-watering flower pot. It may not sound like much, but it illustrated all the benefits of the IoT. So the soil moisture and temperature, it would keep track of that. If the soil became dry, it would turn on a little windscreen wiper pump and pump some water into the pot plant. And if it decided it was time to water, it would then send you an SMS via Lossant to let you know that the watering has been started. So Lossant was a nice one to use because we could actually use that SMS feature. The point with a couple of these free ones is that they are relatively limited. Even when you do pay for them, they still have some limitations, but they are very low cost. If you go to something like, and I've just got the PDF here, the Cisco Connect, it's a different case altogether. And Valerie, I think you've used this previously, but the main reason you would go to something like the Cisco solution for the dashboards and IoT gathering, edge computing, is reliability and security. You don't really know where these smaller, well, not so much small, these free type offerings store their data. You don't know how they transport the data. So if it's sensitive, you really have very little control over what the dashboard is doing with your data and how it's transporting it. However, if you go to someone like Cisco, and we'll get down to their nice little diagram here, we can see that they're a fully complete bundled turnkey type system. So they would provide you with everything you would need right down to the access. And in this way, you can build your security in, you know that your data is traveling, you know what VPNs or other security for the transport you're using is, and it's a reputable company that will always support the product while they're in business. But such a large company, you can assume that they're going to be for a long time. So if there are any technical issues with it, there's a very good chance that they will be able to help you out and give you the support you need for mission critical type applications. So this is the reason you would go to someone like Cisco or the Microsoft Azure platforms, is to get that control and have the security within your application. So they're just a few of the others that are about. So have we got any questions coming up?
No questions, just Sana suggests putting the LinkedIn link in the discussion boards.
Yeah, I'll do that, and I'll put it up on the Facebook as well for anyone who's there. Okay, so we should make sure that everyone has got their results, by the way.
Yeah, if you had any problem with your result, like looking at the list, marked everyone from the list, and is David here? I can see a phone symbol.
Stop sharing my screen.
Oops. Ian, have you heard about this GeoGuessr website?
I'm not sure. It rings a bell, but I'm not certain.
So it's more of an entertainment thing, but it's kind of harkens to the points, some of the points David was making. What it is, it's more of a game, but it gives you a random location on Earth, and you have to figure out. And you can move around the map, and the data is from Google Maps, and you can move around, and you have to determine which part of the world you're in. So,
You want to share your screen and show us if you got it there?
yeah, I'm just gonna browse the free map. Let me set it up and I'll share the screen. Okay. So it's this one, if I'm not mistaken. All right, so it's this thing. It's GeoGuessr. And I'll just hit play. And so yeah, something like this. Then you have to guess which part of the world you're in, like kind of exploring the street signs, and they encourage you to not use Google to search any street names. But interestingly, like they have a community around it where they curate like a list of some places. So because especially with the one the free version allows you to do it for Word, but there are country specific ones that you can like pay for. I don't know. Whereabouts do you think something like this in the whole world would be? So the signs are in English. Are they? Oh no, it's not English. So then you take a guess, say it's somewhere random. Very bad. But it's an interesting thing. Talking to some of the stuff we talked about in spatial sciences and location-based information.
An IoT-based game.
Yeah.
I'm surprised a few of those haven't come up.
Yeah, it's very interesting. Anyway, I'll just share the link if anyone's interested, kind of taking a look at the more entertainment side of IoT, I guess.
I'm just popping in the links into the discussion board. We'll do that in a sec. Okay, everybody's happy with the feedback they got. If you've got any questions on their feedback, please ask. If you want to do it privately, I'll hang around for a little bit after this. We've still got 10 minutes left, but I'd like to add my personal congratulations to everyone. The standard of the projects was exceptionally good. We were very pleasantly surprised by the effort people put in and the results that were achieved. So well done. Particularly in such a, this is not a very long time when you started pretty much from scratch.
And I'm surprised by the number of people who actually got to a working prototype, and I really encourage you to kind of stick around with it and take it one step further to making it smaller, running a PCB for it.
Yes, get those things out there in the real world and commercialized, make a fortune and send your royalties directly to me. We're all poor, starving academics on this side. Except for the rich PhD student.
Yeah, of course, yeah.
All right, well, if there's nothing else, thank you very much. I'll put the details of the LinkedIn up on the discussion board. It'd be really nice if you let us know how you're getting on and how things progress in your IoT career. But once again, well done, and thanks very much for being with us.
I'd like to say my thank you and the feedback I definitely will summarize with additional ideas. I have one specific question. Will it be possible to get maybe your personal feedback? I got the written version in the mail, but I have still extra questions like what will be the hardest thing that you might see. So if you have some couple of minutes, we can do a little private session.
Yeah, I'm sure we'd be happy to do that, wouldn't you, Savash?
Yes, sure. I'm just going through the list to kind of remember which one. Yeah, your idea was the electric scooter, right?
Yes, this is
Yeah.
tracking with speed and identify this.
Yeah, very very interesting, and I think it's going to be a very, like, if you stick with it, it is a very popular thing, because I know like tracking scooters and scooters are becoming very popular now, especially in the States.
Mhm.
And then one of the bigger issues they have is tracking them and then finding where exactly they are and then controlling the speed and make sure the people who are kind of renting them are following the traffic lights and following the speed limit and such stuff. But definitely your idea of implementing that whole IoT solution, I think it's very, very
There
good
is
and
something,
useful.
I'm trying to remember, I don't think you had it, but looking at accident tracking. So if the scooter takes a significant fall, being able to tell them get in for repair or sending out emergency help.
That's something interesting. I was thinking to add at first tracking ability if using beacons. I was not thinking about actually accident detection, but I see that's possible actually.
Yeah, I mentioned
I
because my Skoda's got it. So if you have an accident in this little Skoda and you're in the right country, it will actually call the emergency services for you.
we actually got smart watches from Samsung, if I'm not mistaken, recently installed, a couple of months ago installed. Yes, they do call as well automatically.
Yeah, I think they're trying to get the certificate for it to be able to officially put the call in through emergency services with the latest the Galaxy Active Watch 2 that they kind of introduced to the market. Well, I'm saying latest because it just came out here in Australia, but I think it's been out since early August. And with the heart rate sensor, is that what you're talking about? The heart rate sensor that they have, and then it's trying to kind of predict if anyone has any accidents while wearing the smartwatches.
I think on our side, the Samsung version was based, I think, on accelerometer, detecting the serious drops and
Yes.
falling immediately. But the statistics say that from our, let's say, police department was like, it was 50, roughly like 50-50, like false positive at the moment. I have original, let's say, the question is like, what the hardest thing you see that I need to improve basically to attract, I would say, more people on my site or more possible investors, because it's still like driving alone is one thing, and I see the huge part which I'm still missing is the nicely looking dashboard. Pretty much, I will be setting up the devices on my own in randomly selected places to get data, and yes, that's the plan to get polish it with dashboarding. But maybe I'm missing something. You probably see this.
I think you're on the right track, and especially because I see the potential of you kind of, if you kind of stick with to it and get it to a commercial stage, you can kind of offer your product in two kind of separate versions. One to the company who's renting out the scooters, so they can monitor the behavior and stuff, and one kind of on board on the scooters, mounted on the scooters, so they can get some feedback regarding, say, the speed, and then kind of using one of our other team members' ideas, maybe showing if, because some of them are, these scooter things are becoming tourist attractions, so maybe pinging nearby landmarks and tourist attraction points as well. So kind of, so then if tourists are using them to move around the city, kind of encouraging them to visit those places as well. So there's a great potential of kind of expanding the idea, or you can like shrinking down the idea, or depending on how special you wanna implement it. It's a couple of ideas off the top of my head when I was reading your final report. If Ian has anything else that you can think of, maybe.
No, I think you covered all good.
Excellent, thanks for sharing. And I hope in the future it will be possible to get some recommendations from you as well throughout LinkedIn, throughout Facebook, or throughout email.
Yeah, of course. I think all of us are on LinkedIn, so if you just want to reach out to us more directly, and then I think the IoT capstone email is gonna be left open, Ian, right? Or not?
I think we're going to close it down, but that's out of our hands. That's the CLT who look after the administration of it for us.
I see.
I'll ask them not to.
Okay.
See if we can keep it open.
Thanks for suggestions. Right.
No worries. I'll look forward to hearing what more you end up adding to the project.
Sure.
We'll close off if everyone's happy to do so. I've put those links in the discussion board, so you should be able to get there. Drop us a line, let us know how you're getting on. Thank you and good night. Good morning, good evening, good afternoon.
Thank you again.
Everybody. Bye.
Good night.
Good night, everyone.
I'll check the reporting out in the morning.
Bye. And good night to people in Australia.
Yes.